Welcome to IEEE Project 2013 development. The project title is Radio Database Compression for Accurate Energy Efficient Localization in Fingerprint System. This title under the domain of data engineering. This project developed by the Star Technology and implemented core technology is Java. Next, we see the small explanation about this paper. Radio database compression for accurate energy efficient localization in fingerprint system. This project scope of the project is reduce the computation cost and transmission load in the mobile based implementation. This is our scope of the project. That means reduce the computation cost and and transmission load. Here is in the used more than algorithms, two or more algorithms. So mainly here focused on two-step process. One is the pre-processing. So the pre-processing here using the BCA algorithm and KCA. BCA means principal component analysis, and KCA means kernel convolution correlation analysis. So initial base you can here is divided into two parts to process reduce and compression the reduce signal waves. So training phases you can construct the database, that is the initial phases. Here using supervised and unsupervised learning. So first you can give the initial database. So initial database contains a fingerprint and radio signals to collect the information for various areas. And the processing you can implement at the BCA concept, that means principal component analysis. In this processing divided into two parts. One is the classifier modeling, another one is a regressor modeling. In classifier modeling, here we are using Cannon classifier and Bayesian classifier, and then SVM support vector machine classifier and ANN. ANN means artificial neural network. So here using and more than algorithm based classifiers, and regression modeling using two modeling. One is the support vector machine regression and ANN artificial neural networking. This is the one part of the basis for the training basis, and the localization phase mobile transmission, that means mobile measurement. User get the finger from mobile and transmit to the signal from the training basis. Here also divided into two parts. One is the classification and another one is estimation. That is a localization phase. In classification phase, estimate the position and the cost, and estimation is a position also. So in classifier modeling, Cannon classes using the key sizes one to identify the clustering the training phases simulation. That means you can pass the radio signal to the server. Server collect the information from various client nodes to construct the clustering, that is grouping basis to classifier modeling. Look here, training phases. First initialize the database. After the processing, you can implement the clustering phases. In clustering, here using k-means algorithms. So k-means algorithm to clustering from the radio signals. After that, classifier modeling. That means support vector machine, artificial networking, and KNN classifier also. After that, another one part of the phase is localization phase. In a mobile measurement phase, that is a very important to our project. That is a mobile measurement phase. To here, mobile user retrieve the fingerprint signal to transmit to the server in a mobile basis. That is a mobile measurement. Here is the architecture for the fingerprint system with the database clustering. So in a database clustering contains training phase is a three-step process, and localization phase is a two-step process. Next, radio database compression. Here, 3.1, that means concept of notations. A radio database, it contains a set of records. So, records are assigned to the vectors. So, vector here is in get the information from signal of local location. That the position of the signal you can transmit to the server. Server get the information from the user question from user side. Uh, First, user get the fingerprint information from mobile. Just to push the fingerprint in mobile, and mobile transmit the radio signal to the server through network. Here, server collect the information from each user and save the records in a database. This is a radio database. You can compress the radio database from using different various algorithms. Here using the clustering algorithm to training phase to compression. Um, Here using two different types of feature record. One is a location feature type, another one is a signal radio access technology features. So location means here is get the location is a longitude and latitude based. That means XY coordination version to get the location features, and radio access technology like that RSS, that is a radio signal strength feature. You can get the information about on distance basis. That is two different records. You can keep the database. That is a radio database. You can get the information to measurement the database and compression technique. Here using the our proposed concept is compression in a location of fingerprint system. So here using first category is the pre-processing method. That is processing method using two methodology. One is the BCA, another one is a KZZA. In additional process to processing to applied processing in divided into two parts. One is a classification, another one is a recursion. Processing we can implement the BCA concept and KCCA, and processing also divided into two parts in a training basis. One is a classification, another one is a recursion model. In a classification model, are using various algorithms to compression the fingerprint system and optimize, reduce the computation cost and transmission load. Here using K-means algorithm and then Bayesian classifier. Another one is the stream classifier. And finally, we propose the next level. We propose the feature enhancement algorithm. One is classifying the reduce the computation cost and transmission load. Here using the genetic algorithm based. That means genetic classifier also. Look at this diagram. This diagram randomly placed in the x and y coordinate basis space stations. Nearest dots are the radio is transmitted to the sync node. That means a sync node is the base station. Base station receives the transmission signal from the each clients. This is our simulation figure denoted them denoted dark black color rectangle denoted the base station, and the shadow points are the users. So here using two methodology to calculate the distance. That means position error. Here is find out the two methodology. One is standard deviation, another one is cumulative distribution functions. Next, this is our implementation to test the real implementation. Here using simulation based view test zone. Here this paper implemented to get the radio database from the Paris telecoms to connect the GSM based radio database. First, figure A denoted the test zone of Paris. In this red color rectangle denoted by main phase station. Another square is the range of transmission to the other clients. Another next figure is the phase station of placement to the distant limited flux square. This is the phase station. This uses transmit to the different signals precision ratio here. This is our simulation based selected area to real experiment of fingerprint system to reduce the computation cost and the transmission load in the mobile based implementations. In an existing system, this application implemented in a smallest range, like that room based and Bluetooth and some research based technology here using some fixed set of frequency to implement to find out the location cost and reduce the transmission load. Here we implemented GSM based reduce the computation cost and the transmission load in the mobile based implementations. This is our proposed concept. Here we finally conclusion of proposed technique is GSM fingerprint system. According to the result, reduce the computation cost and transmission load in the mobile system using BWC technique and concatenation to the location ratio in a signal phase and different and attributes are different factor to uh, analyze the time complexity and cost complexity also. This is our paper said that our proposed concept is for the comparison KNN. That's it. We can implement our paper. Thank you for listening and thank you very much.